Hello, algebra students. We're going to do a little more substitution here. This will be a quicker video. Hopefully you're getting some good practice and understanding. If not, come see me, please. I want to help you. All right, remember, we have to have either x or y alone in one of the equations. It's up to you which one to solve for and in which equation, but sometimes you can be really smart. As I look at problem number 1, this system, x plus 6y equals 1, and 3x minus 10y equals 31, the x is almost alone in the first equation. So I'm going to solve that first equation. X plus 6y equals 1. I'll subtract 6y from both sides, and I'll get x equal to 1 minus 6y. Now, I'm going to take this 1 minus 6y, and I'm going to plug that in to the other equation in x's place. So, I'm going to get 3 times the quantity of 1 minus 6y, and that'll be minus 10y. That'll equal 31. I'll distribute over here on the left-hand side. 3 minus 18y minus 10y equals 31. Okay, I'll get 3 minus 28y, and that'll equal 31. Subtract 3 from both sides. I'll get negative 28y equals 28. I'll divide by negative 28 and get y equals negative 1. Well, now that I know that y equals negative 1, I have to plug it into one of 3 equations. I could plug it into the first equation, the second equation, or this third equation right here, the modified form or adjusted form of the first equation. I think equation 3 looks like the easiest one to use. So I'm going to say x equals 1 minus 6. Y is negative 1. So x is going to equal 1. Negative 6 times negative 1 is positive 6. So then x equals 7. So the solution to the system is 7, negative 1. That's the place where the 2 lines cross. All right, one more example. Hold on one second. I got to go put the fish in the oven. Okay, the fish is in the oven and cooking, so I got about 14 minutes, and it won't take me that long to do this problem. So this is a good thing. All right, so I'm looking at the possibilities in this second problem. Which variable should I solve for? X in the first, y in the first, x in the second, or y in the second? Well, I think the 2 best choices are either x in the first or x in the second in this case. And some of you are going to run right to x to the first, and that's okay. You can do it that way. But I'm thinking that equation, that first equation, is so simple, I might want to use it when I substitute. So I'm going to go ahead and solve for x in the second. But like I said, there's nothing wrong with you solving for x in the first. Now I have to get rid of this 3. It's attached by multiplication. So I'm going to divide by 3. But I'm going to divide by 3 in all 3 places. So this new equation will become x equals negative 6 plus 2y. All right, I'm going to take this and I'm going to substitute it in for x. I don't have to distribute this way, so I'm going to get negative 6 plus 2y plus 3y, and that's going to equal 4. I'm going to do 2 steps at once. I'm going to combine these like terms here, and I'm going to add 6 to both sides. So when I add 6 to both sides, I end up getting 10. When I combine those 2 y's, I get 5y. And now most of you can see that y is going to be 2. All right, so y is 2. So now I'm going to plug that probably into this equation here. And I'm going to x equals negative 6 plus 2 times 2. So x is going to equal negative 6 plus 4. So x is going to equal negative 2. So the place where these two lines cross is at -2, 2. That is the solution to the system. All right. Now, by the way, a system doesn't have to have a solution. For example, if I had two parallel lines, where would they cross? Well, the correct answer there is never, right? Those aren't really lines. Let me turn them into lines. There we go. And if I clone that, those parallel lines, they will never cross, right? You could come up with a situation where there'd be no solution. And a no solution problem would end up looking like this. You did all of your work, and then the variables disappeared, and you end up with a false statement. For example, let's say one equation was y equals 1/2 x plus 3. The other equation was y equals 1/2 x minus 5. All right. Well, y is already solved for in one of the equations. I'm going to take this, and I'm going to put it in here. So I'm going to get 1/2 x plus 3 equals 1/2 x minus 5. So I'm going to subtract 1/2 x from both sides. And aren't those going to cancel? And those will cancel. And I'll be left with 3 equals -5. Does 3 ever equal -5? No, of course not. So there's no solution. Now I bet some of the smarter people in the audience are thinking, hey, could there ever be a situation when it's all real numbers? Yes. You'd have to be dealing with the same line twice, and you wouldn't know it was the same line. For example, like if you had y equals x, -x plus 2, and your other equation was, say, 6x plus 6y equals 12. Okay? Well, again, y is solved for, so I'm going to take this, and I'm going to plug it in here. Oh, no, 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 no. I'm going to plug it in here. Excuse me. Not here. So, we get 6x plus 6 times the quantity of -x plus 2 equals 12. And I'm going to get 6x minus 6x plus 12. And 12 equals 12. When does 12 equal 12? Well, it always equals 12, right? They always equal each other. So this would be a case where there are infinite solutions. What it means is this line, let me get a line here. All right, is intersecting itself everywhere. And I'll change the color to kind of give you a better visual here. Let me make it, yeah, that's a good color. And see, it fits exactly on that line everywhere. So the two lines cross everywhere. One way I show it in class is I might do this. I might draw a line and then put an extra set of arrowheads to indicate that there are two lines in the same place. It's actually the same line twice. And so that system has an infinite number of solutions, or all real numbers. All right, we'll talk a little bit more about that in class tomorrow. Mr. Lawrence signing off. Good night, everybody.